So lesson 1.5 is on rearranging literal equations. Notice I said the word rearranging. Solve means something different in this lesson. So literal equations are equations that have two or more different variables, unique variables. So an x and a y, an x, y, and z, two or more different variables. So in these situations, when we solve means something different. It's not just going to be x equals a number, and we can plug that number back in. Solve in this situation, we need to have a variable, the variable we're solving for, alone. So our variable alone on its side of the equation. That's a really basic idea. It's when you talk about this vocabulary-wise, you say, if it's an xy equation, solve for y in terms of x. Okay, so there's some weird physics equations that actually do a really good job of explaining this. So if I'm driving a car, right, so my speed, if I hit the brakes or if I step on the gas, is equal to the speed I started at. And that's a number we should know by looking at our speedometer in the car. That might be like 30 miles per hour. And then I hit the acceleration, and acceleration should actually be a number based on how hard I'm pressing down on the pedal. That one's a little hard to figure out. That'd be harder to measure as one of us. But if you're in a lab, you're testing out a new car, making a new Maserati or something, you'd have some sort of acceleration number. So let's say 10, and that would be miles per square hour, which is really weird units. But then you would multiply by time. So let's just forget about the units right now because that's overcomplicating things. But my variables here end up being velocity, speed, and time. So v is solved for in terms of t. So this is the vocabulary we use for that. Solve for v in terms of t. If I wanted to solve for t in terms of v, I would just have to get t alone. So let's look at a couple of examples. First example, it's really important here that you trust your algebra steps because we're not going to come out to an answer we can check our result with. It's a little bit frustrating, but what we want to do is get y by itself. Now we're going to follow our same four-step process. So in this situation, there's no distributing, no combining like terms. I just want to start moving stuff away from y. So 4x is one term that's added on. The opposite of adding is subtracting, so I can add or subtract an entire term like this. And that's what it looks like. This 4x cancels out, and the minus 4x shows up on the right side. Finally, divide by 3. And I know based on my own experience teaching that this messes with your heads a little bit. But remember, a fraction bar is like division. What this means is I'm dividing each of these things by 3. So 9 divided by 3 is just 3. 4 divided by 3 doesn't come out even, so we can leave that as a fraction. So whenever you have something like this where you're dividing an entire part of an equation by 3, I can divide each thing, each term, by that 3 instead. So I think this looks a little nicer than leaving it as one big fraction. But that's solved. I solved for y in terms of x. Solve for y in terms of x. Get y alone, get x on the other side. Right, let's do another. This problem poses a new challenge for us because there's more than one x. Now this is a skill we'll work on later in the year as well, but what I want you to do is I want you to think of this side as though it's in parentheses, and like think backwards distributive property. Is there anything that's in both of these that we could take out? What I'm hoping you're noticing is that they both have an x. So if I pull one x out front from each of these, it's like I did the reverse distributive property. I'm trying to draw my arrows there to make it look like similar work. The result of that is x 3 plus 5z. So now what I want you to picture for yourself, and this is just to convince you that it's working, is what if I distributed x back in? 3 times x is 3x, 5z times x is 5xz. That's how I would multiply with that variable. I'd come out to what I just had before this. So this is simple factoring, when you just pull like terms, sorry, not like terms, but like variables, like factors, out of different parts of an equation. And again, this next step might make you feel uncomfortable, but I can treat this whole parentheses as one thing. This is when we really start having to explore what we're allowed to do with algebra steps. This entire parentheses can be considered one thing. And since that one thing is multiplied by my x, I can divide it all away at once. It's actually a really nice, quick way to solve this. I just understand that this is not a comfortable algebra step for most of us right now. This should be my solution. X is alone on one side, all the other variables are on the other. Okay, this is, right now I would consider this a very hard problem. This would be a problem I'd put on a test if I wanted to like see if you deserve an A versus an A minus, is if you really understand your algebra steps and your solving steps. All right. There are some equations you'd recognize that we can do this for. One of them is like the area of a triangle. Area equals 1/2 base times height. If we want to solve that for height, if we want to rearrange this equation to get h by itself, we'll have to do algebra steps to get everything else away from it. So I have a 1/2 multiplied in front here. I can get rid of that. I still have to make a review video for fractions, multiplying, dividing, adding fractions. But if I want to divide that away, dividing a fraction is the same as multiplying by its reciprocal. If I multiply by 2/1, that'll cancel out with the 1/2. So I would get 2 times the area. When I read this, by the way, I read this as when I multiply by 1/2, it's the same as dividing by 2. So when I actually think through this in my head, I think, what's the opposite of dividing by 2? If you're thinking of this in terms of multiplying by a fraction, you might want to, I don't know, just practice a little more and start trying to think of things in ways that I do. Fractions shouldn't be that intimidating. It just takes practice and confidence building. But now the b is still with the h. They're still multiplied together, so I'm going to divide by b. And I can't combine that with anything over here, so it's just going to look exactly how it looks now, 2a over b. And that's how I could rearrange the area of a triangle equation. This is the surface area of a cone. And by the way, this is one I definitely don't have memorized. But we want to solve it for this cursive L, which stands for, if I have a cone, the L would be this. The radius would be the radius of the circle on the bottom. And then pi is pi, 3.14. I don't have all the digits memorized. I'm not one of those people. But we're solving for that cursive L. So let's look at what we can do here. It's not necessary for me to factor like I did in the example on the first page, because there's only one L. If L showed up in multiple places, then I would want to factor at some point. So I'm going to start by adding or subtracting things away. These two, the pi and the r right next to L, are multiplied. It's best to save those for last. Just like my strategy on the board, divide by the coefficients, well, that's what I'm going to call those right now, is they're kind of like L's coefficients. So I'm subtracting pi r squared, s minus pi r squared. I can add or subtract whole chunks like that. And what's left over here is just the pi r L. I'm going to divide by the things in front of L, and I can also do this in one chunk. So these will cancel out, and I'm left with s minus pi r squared over pi r equals L. Now I could simplify that just a little bit further. I'm happy with that as an answer if you're able to get there for me. But I can divide the individual things. S over pi r. And in this one, the pi's would cancel and one r would cancel. So it would just be r. I don't know which one you guys think looks better. I have the same number of places to plug in r, so I don't know if one's cleaner than the other one, but these are both completely valid answers. All right, well, that's, really lesson 1.5. It's a short lesson, but it's a challenging lesson. So this is a really good skill, especially moving forward when we get to like graphing lines. Being able to rearrange equations and being confident with it is something that'll really carry with you through future math classes too. So don't brush this lesson under the rug. Really try and get good at it. It's not going to be easy, but it's a good thing to practice and try to build some confidence with.